Alright, hi everyone. Today's class we're going to look at the roots of quadratic equations. Now, let's do a quick recap on roots. Roots are basically a very fancy name for x-intercepts. Alright, it's when the quadratic graph actually intersect the x-axis. So let me show you a positive parabola, and you see when it intersect the x-axis you have two roots usually, right, on the left and on the right. And that is what we are talking about, the roots. Now, the thing is, it's not always that there are two roots. Now, sometimes your quadratic function may have two roots, it may have one root, or sometimes we call it repeated roots, or sometimes it doesn't even have any roots. Alright? And how do we know if there are roots, or there isn't any roots, or there are repeated roots? It all boils back down to the quadratic formula. And I have shown you here the quadratic formula: x equals to minus b plus minus square root of b squared minus 4ac over 2a. So this formula helps you to actually work out the x values or your roots of any quadratic function. Now, we're not going to look at the whole equation specifically. We're going to look at the b squared minus 4ac part, the one inside the square root. Right? That is quite important for us. We call this the discriminant. Now, the discriminant is basically the key component of the quadratic formula that actually tells us if there are two repeated roots, two distinct roots, or there are no roots. Alright? So, we're going to look at three examples here. Alright? And we're going to see how the different examples, by using the discriminant, can tell us about the type of roots that exist. Alright? So, remember, the quadratic part, right, quadratic formula part, b squared minus 4ac, is a very, very important formula that you will use on a regular basis. Now, let's just kind of like try to solve one of these examples. You look at the first example, y equals to x squared minus 3x minus 4. Let's solve it on the quadratic formula. And what you will notice is that, okay, inside the square root, my discriminant seems to suggest to me it is 9 minus 4 times minus 4. And let's work that out. 9 plus 16. And it is 25. So what is so special for the fact that it is 25? Or in fact, we should talk about it, the fact that it is a positive value. So what is the implication? Now, if the discriminant is positive, then obviously when you square root a positive value, you should have a plus minus of 5, right? You should have two values that come out of the square root, a plus minus of something. Now, this happens for any kind of positive value when you square root, right? So, this gives us a very important information. If my discriminant is born at 0, then I will always have two x solutions. Or in this case, we say two distinct roots, right? Both the roots will be different. All right? Now, we say two real roots, but really they are two distinct roots because both of them are not the same, two distinct roots. It is very important that we understand this, yeah? As long as you square root a positive value, you always will have two distinct roots. Now, we're going to look at the second example. We're going to just focus on the discriminant since there isn't a b value. Your b is 0, and there's also no c value, so c is 0. And a is 1, so your discriminant in this case is 0 squared plus, minus 4a, which is 1, and c, which is 0, and you get 0. So, if your discriminant is 0, what does it mean? That means when you square root 0, there isn't two possible solutions. There's no plus minus 0, doesn't really make sense. So, in this situation, where your discriminant is 0, we would have to say that actually there's only one real root. Or sometimes you say it as two repeated roots. Alright, that means only one solution. Only one x solution. Yeah? So, you can think about it as the graph, the quadratic graph, only just touches the x-intercept at one point. Now, if you look at the example, let's see, we work out discriminant, and the A is 1, the B is 0, and the C is 5. We worked it out, and our discriminant is 20, negative 20. But you see, you can't really square root negative 20. You can't really do that. So, would it be possible for you to get any x solution? The answer is no. Because you can't even square root negative 20 to proceed on with the quadratic formula. Right? So, in such a situation where your discriminant is a negative value, you can't find the x values, which indicates to us that there are no real roots to be found. No roots to be found, or no real roots to be found. And this only happens when your discriminant is less than 0. So we say there are no real roots. Alright? So this tree concept of the discriminant is really important. When discriminant is more than 0, we have 2 distinct roots. When discriminant is equal to 0, we have 2 repeated roots or 1 real root. And if your discriminant is less than 0, there are no real roots. Now I just want to show you how it looks like. So 2 real root looks like that. Two answers, alpha and beta. 1 real root looks like it just touches the x-axis, isn't a negative or positive parabola. Just touches only 1 point. So 1 real root, and that is the n-shaped version. Alright, 2 real roots. And if you have no real roots, it looks like it's floating above the x-axis or floating below the x-axis, where there's no intersection. Alright? So I hope this is clear. This is a good, quick tutorial on how to understand the roots of any quadratic equation or quadratic functions. Alright? And what it tells us, basically, the discriminant gives us an idea of the types of roots that we will see for any kind of quadratic functions. Alright? Any questions, leave your comment down below, and I'll be more than happy to answer you, and I'll see you in the next tutorial. Cheers, everybody.